All right, let's talk about one of the biggest chunks of your IGCSE math exam. We're going to build a roadmap for that whole interconnected world of geometry, coordinate geometry, and mensuration.
So, let's start with a big question, right? Why? Why do shapes, lines, and spaces take up such a huge part of your math exam? I mean, what's the big deal with this stuff anyway?
Well, the answer is actually pretty simple. This isn't just some abstract math stuff you'll never use. Think of it as the instruction manual for the world around you. When you master these skills, you're basically learning the secret language of builders, engineers, and designers. You know, the people who actually build our world. Okay, let's dive in. First stop on our roadmap, pure geometry. This is the absolute foundation. It's where we learn the alphabet of shapes and the grammar, the rules that hold them all together. First things first, you've got to know the language. The vocabulary here is, well, it's non-negotiable. You really need to have this mental dictionary for everything from a scaling triangle all the way up to a decagon. And hey, if you're going for the extended paper, you get to add some cooler, more specialized shapes to your toolkit. We're talking about things like the hemisphere and the frustum, which, if you don't know, is basically just a cone with its pointy top chopped right off.
All right, next up, constructions. This is where you get to be a bit of a mathematical artist, but with some really strict rules. Ruler and compasses only. But here's the absolute key. Getting the final shape right is only half the battle. The examiner needs to see your process, the story of how you built it. You see those little arcs you draw with your compass? That's your proof. Whatever you do, do not erase them. Okay, now listen up, because this is a detail that really separates the top students from everyone else. Finding the angle, that's just the first step. To get all the marks, you have to think like a lawyer. You have to present your evidence, and that means stating the official geometric rule you used to get your answer. It sounds so simple, but believe me, this is where so many marks are just thrown away.
And you know where this really comes into play? Circle theorems. The jump from core to extended here is huge. Think of it this way. Core gives you a couple of really useful tools, but extended, you get the whole advanced toolkit packed with these super powerful theorems that can crack complex problems in just a couple of moves. It is absolutely critical that you know which toolkit you're supposed to have mastered.
So we've learned the language of shapes, right? What's next? Well, now we give them an address. We're going to take all those abstract shapes and rules and anchor them onto a map, the good old Cartesian grid. That's right, welcome to coordinate geometry. And, no surprise here, we see that same step up in challenge. For core, you're kind of like a detective with a map. You're spotting clues visually. But for extended, oh man, you become a full-on strategist. It expects you to calculate everything, gradient, midpoint, length, using nothing but coordinates and algebra. And that new weapon in your arsenal? It's all about mastering that amazing relationship between the gradients of perpendicular lines. And all of this, it all leads to our final stop, mensuration. This is where the theory hits the real world. This is where you take everything you've learned about shapes and coordinates and you use it to answer really practical questions. Questions like, how long is this? How big is its area? How much stuff can it hold? This is the math that builds things.
Okay, a really vital exam skill right here is knowing what's on the formula sheet and what's not. Yeah, the exam gives you a bunch of them for circles, cones, spheres, all that. But, and this is crucial, some of the most fundamental ones, like the area of a trapezium, nope, they don't give you that one. You just have to know it. You absolutely have to have that one memorized, cold. And speaking of things you just have to know, let's talk about a classic exam trap just waiting to spring on you. Units. Look, when you convert an area from square meters to square centimeters, your brain screams, multiply by 100, but that is dead wrong. Because it's an area, you have to multiply by 100 squared. That's 10,000. It seems like such a tiny detail, but getting it wrong can make your entire beautiful solution just completely fall apart. You know what? Since we're on the topic of traps, let's go a little deeper. I want to show you the two most common, highest stakes mistakes that students make year after year after year. Let's break them down so you can avoid them. Yeah, we've touched on this already, but it's so important it needs its own special warning. Trap number one is just vague reasoning. Writing something like, because it's in a semicircle, will get you exactly 0 marks. Why? Because that's an observation, it's not a reason. You have to state the full formal property. The angle in a semicircle is 90 degrees. Remember the analogy. You have to name the law, not just point at the crime scene. Okay, trap number two.
This is a huge one, especially for extended students, and it's all about similar 3D shapes. So, imagine this. A student correctly figures out that the length scale factor between two similar pyramids is 1.5. Great. Now they need to find the volume of the bigger pyramid. So they take the volume of the small one and they multiply it by 1.5. It feels so right, doesn't it? It feels intuitive, but it is 100% wrong. It shows a complete misunderstanding of how scaling works when you move between different dimensions.
Here's the rule you need to burn into your brain. Scaling works in dimensions. If you're dealing with length, you use the scale factor. If you're dealing with area, you use the scale factor squared. And for volume, you guessed it, you have to use the scale factor cubed. So the right multiplier isn't 1.5. It's 1.5 to the power of 3, which is 3.375. That is a massively different answer. And trust me, that's where the top marks are.
So we've taken this whole journey, right? Through shapes, coordinates, and measurements. What's the one big idea, the golden thread that ties all of this together? What's the single most important thing you should take away from all this? It really all boils down to one word: precision. And you get there with 3 simple habits. Habit number 1, annotate your diagram. The second you find a length or an angle, write it on the picture. Habit 2, justify every single step. State your reasons clearly, like you're making a case in court. And habit 3, always check your units. Always. Get these 3 habits down and you are on the path to success. Because at the end of the day, mastering this stuff isn't just about passing a test. It's about learning a powerful new language. A language you can use to describe, analyze, and even change the world around you. It's one of the most fundamental tools for creation we have. So the only real question left is, what are you going to build with it?